All right. Hello, everybody. So yesterday we were talking about, we talked about pandas and how we will be using for extraction transformation of the data in pandas. Today also we are going to stay in the machine learning at the paradigm of data itself. Not going to the model and matrix yet. Matrix or learnings yet. We'll be staying still in a realm of data itself. Here's a quote. The good machine learning engineers focus on model and metrics. The great ones focus more on data. All right. In fact, you will be spending a lot of time working, looking at your data, exploring your data, and that leads to EDA. So today we are not going to be exhaustive in EDA, that we are going to cover everything in EDA, but we will be developing a very solid framework for EDA. What is EDA? Exploratory Data Analysis. All right. And there are certain things that we'll be doing in EDA. What kind of things you think we should be exploring in our data before going to the model or before going to the developing the model and doing the metrics? What should I be doing in EDA? What all things?
Finding this mean.
Standard deviation variance.
Standard deviation variance. All right, we'll go over there.
Finding the mean, probably.
Finding the mean. But
Missing
standard
values.
deviation are for which kind of variables?
Integers.
Yeah, numerical variables, right?
Yeah.
We'll be having it for numerical variables. So firstly, EDA, we have to distinguish between this thing, that what kind of features or what kind of columns, remember that we will be having. We'll be having numeric in nature, and we'll be having categorical variable. Categorical. All right. So firstly, identify in your data what are the numerical variables, what are the categorical variables. And then once you have that, the first thing that we should be using is looking at the distribution of the features. Distribution of the features. All right. What will the distribution of the features tell us? For example, if I looked at the, yeah, go ahead.
If it is a relationship between two features like bivariate or univariate, like how we have it.
We will be doing the univariate analysis also, bivariate analysis also. But in the distribution of the features, we will be looking at the skewness as well. How skewed is your variable? Why is it handy? If you want to look at a feature or a variable, and its distribution is right skewed, long tail or thick tail. If we have the knowledge about that, then we can transform those features. For example, if it is right skewed or thick tail, then we can use the log transform. Log transform the data. An ideal candidate, for example, is salary. This is the majority. Then I will be having some minority like Adani, Ambani. They will be having much more salary than some other people. The top 1% will be having a lot of salary. If I do not take the log transform, then I'll not be able to get an unbiased model. Another thing that the distribution will tell us, remember, there are missing values in the data. For a particular feature, whether I should be using median, mode, will be dictated by the distribution of the feature or distribution of the variable, numerical variable. Make sense? Yes, Suhas, go ahead. What's your question?
Question, did you talk about what categorical variables are? And second, when you
Yes.
say right skewed, you mean more.
Numerical variables are the ones that are numerical, the other ones are categorical. For category, for example, yes, no, low, medium, high. All right.
Oh, okay.
Those are
And when you
categories.
said right skewed, you mean more outliers towards the right side of this graph, right?
This kind of distribution. Make sense? This kind of distribution, where we have this as a frequency or the count, and this as the salary. Example, 100K. Everybody else has, all the Indians have 100K, and everybody else has maximum 25K. Like less than 100K. All right, that kind of situation. Does that answer your question, Suhas?
I mean, why is it right skewed then? Because
Skew towards right.
okay, more okay, makes sense.
Okay.
Yeah.
Left skewed will be like this. Okay. So distribution we should be looking at. What else we should be looking at? We should be looking at the missing values. And how do we check the missing values? Yesterday we talked about it.
Isn't it?
Zen.
And then we will be having different strategies for the missing values. And we will discuss in our class that there are 3 different kind of missing values that we will be having in our data. One is MCAR, missing completely at random. MAR, missing at random. Then MNAR, that is missing not at random. So we should be looking at the distribution of the variable. We should be looking at the missing values. And among the missing values, we should be trying to identify whether it is missing completely at random, missing not at random. And then we'll see the strategies, how to handle those missing values. Not everywhere I should be plugging in with the mean. Make sense? So we'll go to the root causes and we'll try to figure out how to handle those missing values. The next step that I should be doing is looking at the outliers. For example, we are trying to figure out the house prices in a neighborhood. But Suhas is a celebrity. Everybody is buying the house for 100K, but he has a lot of money. He has bought it for $1 billion. If I use that data for trying to figure out the house price for the ordinary people like me or Akshay, then that outlier will give us a bias. All right. So depending upon the use case, I will be looking at the outliers. If it has to be eliminated, we'll eliminate it. But if it is West Hollywood Hills, where everybody is a celebrity, where everybody is an outlier, then probably I'll not be deleting the outliers. But identifying the outliers is important. And the naive machine learning engineers think that all the outliers have to be eliminated. But if your use case is this, that it is West Hollywood Hills, and where everybody is a celebrity, then we cannot remove the outliers. Or we have majority of the celebrities over there, then I cannot remove the outliers. But identification of outliers is important. Correlations. We have to identify the correlations between the features. Why?
Because like maybe one feature is either improving the speed, like it's having an impact on the skewness of data. Can you say that?
Okay.
Because that relationship.
Say that again.
I was going to say that relationship will help us determine the function that governs the classification or the prediction.
If we have correlated features now, a lot of times it's generally bad. Why? There are 2 kinds of correlations I can have. One is a feature target correlation. For example, yesterday we saw an example that in the churn data set, whether the customer is going to churn or not, there is one target variable for that, churned. Another, if we have a column like refund after churn, then refund after churn is directly going to give me the target leakage. it is going to directly give me a signal about the target. I do not want that. Make sense? So one is feature target correlation. If I have a direct correlation of my feature with the target, dangerous. I should be dropping refund after churn column. The other kind of correlation which can be there will be between feature. For example, house prices. If the area is given the square feet as well as the square meters, 2 columns, should I be considering both? No. Should I be having number of rooms and areas of the house? Both, they'll be strongly correlated. Maybe I should be deleting one of them, because both of these features will be giving you the same signal. If I'm having the correlated features in my model, then I will be having a problem of multicollinearity. Kindly keep noting these words now. These are the words that you'll be using in the interviews. I will be having a problem of multicollinearity, especially in the linear models like linear regression or logistic regressions. That's why looking at the correlations is very, very important. The next thing that we should be checking in our EDA is data quality. Data quality. All right. In the data quality, I should be looking at duplicates, inconsistent, remember yesterday we created a data frame multiplied by 25,000. It was basically repeating all those only 20 rows, 25,000. Will it be able to give us any signal? I will be very happy that I have 1 million rows. But effective rows are just 20 only. So duplicates are not going to help. The inconsistency in the data quality is also going to lead us to certain decisions that, or the certain actions that I should be taking. For example, inconsistency in the target. It will be written yes, it will be written bigger yes, it will be written y yes, it will be written true also somewhere. The data quality will be all over the place. Make sense? And then we'll talk about something called cardinality also. Cardinality, especially belongs to the categorical variable. I should be looking at different cardinality of the categorical variables, that what are the different types of the categorical variables. For example, Vibgyor, I have 7 types of the colors. If I have low, medium, high, then 3 categories. That's cardinality. Why is the cardinality required? Because tomorrow we have to encode the data. Remember, as a mental model, I might be having categorical variables, but I have to convert them to numbers. The computers understand numbers, they don't understand the string. I have to convert them into numbers. I have to encode that data into some numerical values. We can use label encoding, we can use one-hot encoding. We'll talk about these encodings when we go to the model. But that tells us, that exploration of the data tells us that what kind of encoding that, or how, not what kind, what should be the strategy for encoding, that is, how many categories in numbers you will be having. Make sense? Rupesh, you had a question. Go ahead, please.
Yeah, I think you mentioned about correlations between features, right? So do we check like correlation between each and every feature with every other feature? Like if there are 10 features, then you check like with all other 9 features.
Ideally, you should.
Okay.
Ideally, you should. All right. Especially if you have very lesser number of features. All right. But your concern is absolutely correct. For example, if I have 30 features, I can do the correlation between each and every other. But in these days, the AI or the frontier models are using 150,000 features. All right. If I start doing the covariance check on that, then I'll keep on doing until the cows come home. All right. So how do we handle when we have multiple features, multiple dimensions in our data? Anybody knows that?
Dimensionality reduction.
Perfect. Dimensionality reduction. We can do PCA. And PCA is basically based upon the covariance matrix. It looks at the covariance of the features. Make sense? So we can do PCA, that is, we can do the dimensionality reduction, which is basically based on the covariance matrix. All right. And even if we want to look at the covariance, your assumption is that we will be doing one by one by one. All right. We can make a covariance matrix. And who has the capability of doing that? Our very own NumPy. Makes sense?
Yeah.
The compute engine that we have. All right. And in the correlations, we'll see that if we have the correlation, there are different kind of correlations also. One is linear correlation. Another one can be non-linear correlation. We have different algorithms to detect that also. We'll see among them. But this is a general framework that we'll be using for EDA initially. Anybody any questions till now? All right. So now when we are looking at the numerical variables, at that time, we will be looking at numerical and the categorical variables. We'll be doing something called univariate analysis. Uni means one. For a single variable, I will be doing univariate analysis. Very important. All right. In the univariate analysis, firstly, what should I be looking at? The distribution. If it is a numerical variable, then I should be using dot describe, which basically gives us mean, median, mode. Percentiles, we'll see it. It can give us percentile. All right. The next thing that we can do is, if we want to look at the distribution of the single variable, what can we do? One is using the describe in Pandas. That is looking at the summary statistics. Anything else we can do for looking at the distribution that we talked about? We want to look at the graph, right? How is the distribution? For a single variable, what is the best way of looking at the distribution of a single variable? What kind of graph is handy?
Histogram.
Histogram. Makes sense? Histogram. In fact, we will be building 3 or 4 histograms today, which is basically the counts and the distribution. For example, like this, like this, like this. If I have, then this is basically giving us this kind of distribution. Makes sense? And then after the histogram, what we can look at is look at the skew using skew function also. All right. This will tell us the skew is right skewed or left skewed. All right. Why? Because we have to do the transforms. All right. If it is right skewed, then the skew will be giving us be greater than 0 value. If it is lesser than 0 value, then it will be giving us left skewed. All right. This is for numerical variables. Describe, histogram, skew are some of the things that we can look at. But univariate analysis is for numerical and categorical both. This is for numerical. For the categorical, what should I be doing?
Value counts.
Value counts. Value count. How many zeros are there? Sorry, how many? Value counts. What is the frequency counts? And then cardinality. What are the different types of the categorical variables that we have? Make sense? So these are the things that we can do in the univariate analysis. In fact, we will be doing them today for numerical and then for the categorical variable. What to look for in the univariate analysis? What is the skewness? We have already talked about it. Next thing that I should be talking about is outliers. We have already talked about it also. We should be looking at zero inflated. This we have not talked about it. If we have a lot of zeros in our data, then that is bad. For example, in revenue, I might be having 1 million rows. 1 million rows, I have 0, 0, 0, only one. Make sense? This. So zero inflated and cardinality we have already talked about. That in the encoding strategy will be telling me about how the encoding strategy will be decided by the cardinality of the variable. Now this is univariate analysis. This is a univariate analysis that we will be doing for all the features. But I want to make a special Oscar or special award for one particular variable, and that is the target variable. All right. We should be surely doing the distribution of the target variable. If it is numerical, we should be looking at the skewness distribution, summary statistics, the histogram of the target variable. But if the target variable is categorical, let's talk about that. One special thing I should be looking for in a target variable is what?
Class imbalance.
Perfect. Class imbalance. I should be looking at class imbalance. And in real life, actually, you'll see that a lot of data is actually class imbalance data. Fraud detection in Stripe or in the financial companies. 100 people, 99 people will not be doing any fraud. One will be doing a fraud. We have to catch him. Churn. Mostly, customers will not be churning, but some of the customers will be churning. We have to detect that. Makes sense? The class imbalance, when we have done it in EDA, will be dictating three things. Remember, data dictates the model as well as the matrix. In the model, it will be dictating that how do we stratify our data. Stratification means that I need to have equal representation in the training data as well as the test data, equal proportion. It should not happen that in my training data, I do not have any fraud detection on, and all the fraud detection are getting concentrated in a test data. Make sense? I have to sometimes decide about that if we have class imbalance, what is the threshold that we should be using? We'll see it in logistic regression. What is the threshold where we categorize a variable, whether it is fraud or not fraud? Not at a probability of 0.5, probably more probability. So that also is a decision that will be dependent upon the class imbalance. In my model, in my matrix, the class imbalance will be dictating whether I should be using the matrix like accuracy or whether I should be using the matrix like precision recall or PRAC, precision recall area under the curve. Let me give you a small glimpse. If we are doing a disease detection, only 1% of the people have that disease. It should be pretty rare. Nitish comes and he doesn't make any model and he says, I'm going to say everybody is healthy. His so-called model, which is basically a random model, will be giving us 99% accuracy. Rupesh will say, oh, Nitish is awesome. His model is giving 99% accuracy. But his model is return true. That there is no disease. Does that represent that Nitish model is really great? Nope. That's a bad metric that we have chosen. We should have chosen precision recall as the metric, confusion matrix. So the class imbalance will be dictating our decision in the model and the matrix. That's why we should be focusing specially on it when we are doing the EDA. Let me take the question. So ask, go ahead, what's your question?
Why is class imbalance a problem? As in, is it because all the data could get split into the test?
No,
I mean, the
class
imbalance.
imbalance is a problem because we have the very less class, very less amount of data of the class that we are trying to detect. And it will be, if we don't take care of it, if we don't take care of it at the model level and the matrix level, then our decisions will be incorrect. Just the example that I gave is that if we have a class imbalance and if a model is return no disease, all right, is that a good model?
But imbalanced class will also go into the training and will influence the decision, right? Even if
let it go. But how do you detect whether it is a good model or not? Based upon the matrix, right?
yes.
And if you don't know that there is a class imbalance, invariably you will use some random matrix, right? Let's say you use the matrix of accuracy. How do you benchmark whether your model is good or not? Make sense? That is just at the matrix level. All right. Now, if your model has just the data in the training data of the majority class, which is no disease, will you be able to make a good model? So you'll be making the mistakes not only at the model level, you'll be making mistakes at the matrix level also if you don't know that there is a class imbalance in your data. And this is very common. Class imbalance will be invariably asked to you. If you're going for any of the interviews, you will be asked for class imbalance at every place, all right? In the data, in the model, at the matrix level also. There are 3 remedies. I'm just giving you a glimpse of what's coming in. There are 3 remedies that we can do for the class imbalance. One is at the data level, that if you have very less representation of the prediction class that you are trying to do or the minority class, then you have more data. That is at the data level. The second step is at the model level, you stratify your data, you choose the right hyperparameters. If there are hyperparameters which are going to be dictated by the class imbalance, then you adjust that. The third one is the matrix. So all 3 paradigms of machine learning will be affected if you have class imbalance in your data. All right. Now, these are the things that we'll be doing in the univariate analysis. We have already talked about it. Now comes the bivariate analysis. Univariate analysis, in fact, is more bivariate analysis. Univariate analysis is super important. Some people think that, okay, it is only the bivariate analysis matter. No, it is the univariate analysis which matters a lot. So between the bivariate analysis, that is between 2 variables, examine the relationship between a pair of features between 2 variables. And how do we check it? First thing that we have to check is the correlation. Now, there are 2 kinds of correlations. This correlation, if we are checking, this is called Pearson's correlation. All right. Pearson's correlation is what? It is basically looking for the linear correlation between the 2 variables. And then we can check the nonlinear correlations also. That is called with Spearman's algorithm. We can check for the nonlinear correlations also. Makes sense? Now, if 2 variables are very correlated, then we can drop one of them. For example, if the correlation is greater than 0.8 between 2 features, then I can drop one of them. Correlation is basically going to lie between -1 to 1. So if it is greater than 0.8 or smaller than -0.8, then that is one of the decisions that we can make, that we can drop one. How do we detect the correlation? And what is the difference between the correlation and covariance?
Covariance could be, the range of it could be very high.
Yep, it can be between
for-
-infinity to infinity.
But directionally, they are the same.
And actually, they are same. Very important. Very nice. These are the kind of things that you should be knowing. Directionally, they are same. They are trying to give you the relationship between. There is a subtle difference. Correlation is basically normalized covariance. Listen to this again. Correlation is basically normalized covariance. So if we are looking for covariance of X and Y, basically we are looking at that if we are, in English, if we are increasing x, what happens to y? Is it increasing linearly with x? It is decreasing linearly with, inversely with x. That gives us covariance. Basically, sigma between k is equal to 1 to n, xi minus mi, and yi minus ni. That is the means. And correlation is nothing but covariance of x and y divided by sigma standard deviation. Normalize it with standard deviation. So that minus infinity to infinity comes in the range of -1 to 1. That is sigma x and sigma y. So don't get confused when we are talking about the covariance and correlation. We will be remembering Ajay's golden words, that they are directionally the same thing. All right. So if there is a correlation, then we will be dropping one of the features. That is what we can do in the bivariate analysis. The next thing that we can do in the bivariate analysis is, in this, correlation is between numerical and numerical. Number and number are, that I forgot to mention, numerical and numerical. What if we have numerical versus categorical? All right. One numerical variable, one categorical variable. What should I do in that scenario?
Should we encode categorical before?
We will be encoding the categorical variables, but still, encoded value will be categorical only, right? It will not be continuous. What should I do in that scenario? We do something called slice analysis. All right. Remember one thing. EDA is done before the normalization or standardization of the data. Exploration is done before we are scaling the data, normalizing the data, standard scaling the data. Same thing. So scaling, standard scaling, normalizing of the data comes after you have explored. Make sense? Encoding, we are going to do scaling on the numerical variables and encoding on the categorical variables. So this part comes after EDA. Make sense, Nitish? So I cannot encode it first because I have not explored the data. So we go in a logical manner. We do the EDA first. In the EDA, between the numerical and the categorical variables, we'll be doing a little bit of slice analysis.
Makes sense.
For example, for the target variable, we will be looking at the churn rate. Among the distribution or among the univariate analysis, for a target, I will be looking at the churn rate. If churned is our target, then we'll be looking at churn rate. How much is the churn rate? Make sense? Churn rate will be giving us the class imbalance also. And if we have a class imbalance, but according to a slice, that is for India, there is churn rate. For US, there is no churn. I will be able to make the bucketing, or I will be able to do the slices now. And I will be able to know that probably if I don't have any churn data from US, I should be collecting it. And that's where the slice analysis comes into the picture. Example, with the target variable I have. Make sense? If I don't have any representation of, I have an age less than 25, but I don't have any data belonging to the premium plan of Netflix, will I be able to detect that what is the people below 25, are they going to churn or not going to churn? So these are the kind of things that I should be looking in the slice analysis. Numerical versus categorical variables. Then we have categorical versus categorical variables. In the categorical versus categorical variables, what should I be looking at? We should be looking at crosstabs. Something like this. A crosstabs graph. All right. That for India, it is yes. For you, it is no. That kind of thing that we should be looking at. But we cannot miss the numerical bivariate analysis and the numerical versus categorical bivariate analysis. Categorical versus categorical can give us some information though. So that's about, okay. What kind of graphs? That I thought about. In the bivariate analysis, remember in the univariate analysis, the graph that we took was for one variable histogram. Between the relationship between two variables, numerical versus numerical, what kind of graph that I can use?
Scatter plot.
Perfect. Scatter plot. We can use a scatter plot. We can use a scatter plot between two variables. Got it? In the numerical versus categorical, what is the graph that we can use?
Bar chart.
Bar chart. Very nice. All right, bar chart. So when you are doing the exploratory data analysis, these are the things. Equivalently, you keep on seeing that what kind of graphs that we can look at. Okay, so this is about univariate and bivariate analysis. Let's go to the missing data patterns. Very important that we have the missing values. We have explored them, but before doing randomly filling the missing values, I have to understand the category of the missing values. One is MCAR, missing completely at random. Missing completely at random. Got it? That MNAR, missing at random. Because if I don't know that what is the reason that they are missing, then I will not be able to take smart decisions. And average machine learning or AI ML engineers thinks that all the missing data are filled with medians and modes. No. We have to understand whether they are MCAR, MAR, and MNAR. What is missing completely at random? What do you think will be there?
There is no reason behind missing.
There's no reason behind it. Jyoti went, she collected the data. She was uploading it with the pen drive. In the pen drive, few of the rows got corrupted. All right. Or Ajay is a data collector. His last line got folded, or the paper got torn. So missing completely at random. It is not intentional. Not intentional of my data collector also. Not intentional of the person from which we are collecting the data out. Then comes the category missing at random. In that category, missing at random means what? That we are collecting the salary. Pooja is collecting the data. She went to a 14-year-old kid. And she asked, what's your salary? And he says, he does this. He says this. All right. And Pooja did this. All right. Or we went to the senior citizen. Jyoti went to the senior citizen. And she asked him, an 85-year-old person or 95 years old. He is just walking like this. What's your salary? Are you going to what time you are going to the work? And she said, what? All right. All right. That is missing at random. That probably the data is not possible for that category. For the other, doesn't mean that, okay, Jyoti stops asking 25-year-old people or 35-year-old people that you are also working from home. Not that kind of scenario. All right. MNAR, missing not at random. Pooja and Jyoti are collecting salary data. Shanika is super rich. She's Adani, Ambani. Now, she's not going to tell the salary data intentionally. That is not missing at random. And that signal is very strong. Although data is missing, signal is going to be very strong because Shanika is also not going to report her salary because her salary is 1 million. Suhas is also not going to report his salary and his salary is also 2 million. But if we are detecting a model in which spending power or who is going to buy our premium plan, we want to push it like smart businessmen. Then that missing, not at random, actually will be giving me a signal that they are not telling. Why? Because they are very rich and they will buy premium. Make sense? That is missing, not at random. Now comes the strategies. How do we handle the missing, not at random? Jyoti,
Before that,
yeah.
But looking at the data, how we can see like, okay, fine, which strategy is basically, if it is MCAR or MNAR, right now we know, right? But if I get the data.
Missing at random, you'll know that age 14, na?
Yeah.
And that's how we'll know. Age 14, age 85, that is missing at random.
Yeah.
All right. MCAR, you will know that, okay, missing completely at random. Doesn't make any sense. Make sense?
Okay.
But between MCAR and MNAR, there will be a contest. All right. So what you will do is, for MNAR, firstly, you do not delete that data. You do not assume that it doesn't have a signal. You assume that it has a signal. Make sense? So if you have the categories for the data, it is a categorical variable that you are talking about, for which you do not have the values are missing, not at random, then the situation will be, I will be having low, high. And then we will put a flag is missing. And when you are doing the analysis, suddenly you come to know that is missing flag people are the ones who are buying the premium most. And you will be able to detect that is missing flag that you have, an assumption that you made is a valid assumption. It gets validated. Make sense? So if this is not giving you a signal, all you have to do the bivariate analysis, not enough, then slices that is missing people are buying them. Then you know that I need to add a flag for the missing not at random. If that is not the case, then you can do MCAR. Missing at random, you will already know from the analysis that you are looking salary versus age, who all, slice analysis again, who all people have the missing data. Less than 14 years or more than 85 years. That you'll be able to handle. That either for that bucket, I put 0, or I put what is most common for that category. It may be possible people less than 16 years are working as TAs or RAs. So if the most common among them or the average among them is $14 or $10 an hour or $500 a month, then you can put their salary as $500. According to that bucket of age, and we'll see how do we do the bucketing, how do we do the binning in our EDA. Today we'll see. All right, you can handle the missing at random like that. Missing not at random MCAR, you can handle it like this, that you don't assume that missing completely at random. You assume that they are missing not at random. If that is giving you a signal, then it is MNAR. If this is not giving you a signal, it is MCAR. If it is MCAR, either you delete the data, or better, you use a strategy. The strategy is that you have to replace the data with the median or the mode, depending upon distribution. Make sense? This is a good way of handling the missing values. All right, let's go to the next part that we'll be discussing before we go to the lab. That is correlation analysis. We have already talked about. There are two kinds of correlations between. One is linear correlation, then there is non-linear correlation can also be there. If the correlation value is greater than 0.8, then it can lead to the problem of multicollinearity. I should be deleting one of the variables. All right. Then the outlier detection. How do we detect the outliers? We said that we are going to detect the outliers. How do we detect the outliers actually? Anybody?
Box plot.
Huh?
Box plot.
We can do it with the box plot. That is at the histogram level. Perfect. Histogram level. Oh, sorry. That is at the graph level. We can have the box plot. Amazing. So if you see, the idea behind this discussions is we are having the graphs and the other side that, okay, what are the different strategies of with the NumPy or the pandas that we can. So with the graph, box plot can give us what are the outliers. Any other way? Remember
We can
Z-scoring?
see the we can see
Remember
the
60?
threshold and calculate. Like we can see the threshold and then calculate.
Z-score? The threshold will be decided by the distribution, right? Remember Z-scores? If I take the Z-score of a variable, then 99% of the data lies between 99% of the data lies between 3 sigma. If we have done the standard scaling of the data, anything which is lying outside 3 standard deviations is going to be an outlier. That is the Z-score way of removing the outlier. Yes, Ajay, go ahead. What's your question?
No, it's not a question. Interquartile range 1.5 times IQR.
Yep, we'll come to the interquartile range. One of the strategies is Z-score. Another one that we can do is IQR. That is interquartile range. Is it quartile or quantile? I think it is quantile.
Yeah, quantile.
It's quantile. All right. Interquartile range. Basically, what we do is not quantile. It is another way of checking the distribution. And in fact, we can have the interquartile range like 5. If I want to have 5 distributions, 5, 10, 25, 50, 95. All right. If anything which is lesser than 5% and more than 95% quantile range, then we can eliminate them out. That is the way that we can handle the outliers if we have to delete the outliers. Okay. I'm not saying that every time you have to delete the outliers also. Depends upon your use case. All right. Now, feature engineering insights from EDA. What kind of feature engineering insights? After that, we have done the exploratory data analysis, then we have to prepare the data for the model, right? And this is what we are talking about, the scaling or the encoding. We have already gotten the signals from the EDA. If we have to find if we have to do the feature engineering of what is feature engineering? What is feature engineering?
All of the encoding that we discussed.
No, encoding is not
modifying
feature engineering.
Yes.
Encoding is different.
Reduction of features.
That is dimensionality reduction. That is feature reduction.
Combining features, multiplying, dividing.
Combining the feature. All right. Either we do the feature engineering, we make a transform on that feature. For example, for salary. Remember, we have not done the scaling yet. Scaling will come later. Firstly, we are trying to have the correct kind of distribution. If it is right skew, we are trying to have a consistent kind of distribution. So we can do the log transform, and after the log transform, also we can do the Z-score scaling. Make sense? We can do the log transform. We can do the box-cox transform. We can do the logic transforms, different kind of transforms. So a feature is changed either directly, or what we do in feature engineering is that we combine a couple of features to get a better signal feature. For example, if you have two variables, one is balance amount of the bill and paid bill. If I say one of the samples, one of the candidates, Alok, has paid an amount of $1,000. All right. And another one is Akshay, who has paid $100. All right. And the target that we are trying to decide is default. Who is going to default on our loan? Does the paid bill give you any signal individually? We might think, oh, Alok has paid $1,000 and this guy has paid $100. So Alok is not going to default. But if I look at the balance amount for Alok is $1 million. Balance amount for Akshay is $200. That's it. Now the perception changes. Who's going to default? Alok. So it's not only the paid amount individually or the balance amount individually which is going to matter. What is going to matter more? Ratio of the paid. The ratio of the paid. Paid versus balance. So if I have 1,000 divided by 1 million, what percentage of the remaining amount he has paid is going to matter more? This is the feature that we have engineered from paid bill and the balance bill. This will be giving you more signal than the paid bill individually or the balance bill individually. This is the feature that we have engineered. Does it make sense? Yes, Alok, you had a question. Go ahead.
No, I don't have any question.
All right. Any other way of, for example, there is 3x probability or 3x more chances for people to survive on Titanic if they have a higher value ticket. Rich people. All right. So we will be trying to engineer a feature, whether I should be taking a log on that or whether I should be multiplying 3x. So looking at the EDA, we will be making these decisions about feature engineering. For example, skewed distribution, salary, feature and engineer to log transform. That is engineered. High cardinality, categorical, variable. What should we do in that scenario? Hash encoding or target encoding? Encoding. Hash encoding. All right. Missing values with pattern. We have already talked about it. Missing values with patterns. In that scenario, what should I be doing? I should be adding is missing flag. That was the discussion that we had with Pooja. Make sense? Date column. We already saw it yesterday. We engineered a feature, or we engineered another feature. Why? Because the complete timestamp will not be giving us any signal. What can give us? Date, weekend. From the date, you can have the weekend also. On the weekend, people will be drinking more. If your model is detecting who will be drinking more and on what days, then the timestamp is not going to help. Weekend, not weekend, is going to help. We can engineer a feature. It's weekend. Make sense? And then two correlated features create a ratio or a different feature. If there are two correlated features which are very correlated to each other, X and Y, we can engineer a feature that is 3x plus y, which is equal to z, and drop these, use this. Some ratio or some combination of the other two features. This is what the EDA can lead. Now let's summarize the EDA checklist that we have to do as machine learning engineers before we jump into the models. Is shapes and types. Look at the shape and type of the data. What does type tell us? Numerical or categorical variables? Data type. Makes sense? And if it is numerical variable, int 64, float 64, which one? All right. Then summary and summary statistics, mean median modes of the numerical variables. Some of the checklist items. Missing values, we have already talked about missing values. Then distribution, we have already talked about. This is just a checklist or the revision of what we have discussed till now. Target analysis, class imbalance will be dictating data, model, as well as matrix. Correlations, we have already talked about it. Drop the correlated features. Or do correlated features have to be engineered into a separate one? Outliers, we have already talked about it. Remove them or not remove them based upon your case and duplicate. Or whatever we have talked about till now in the first hour of discussion about our EDA, all those things we should be doing. Yes, Ajay, go ahead.
Can you throw some light on ordinal features? So ordinal order, like let's say high, medium, low income individual, let's say 1, 2, 3. If you encode them as 1, 2, 3, there is order in it, but it's not random categorical feature.
This can go to the order. Okay. This will go actually to the model level, but I'm going to give you a glimpse. Okay. But if not everybody gets it, then it's fine. All right, because we are going to do it in detail. I'm going to bring some model aspects into it. Okay. So if we are developing a linear model, for example, y predicted value is W transpose X plus bias plus noise. This is the linear model that we have. We'll be using it for linear regressions and logistic regressions. If we have a feature which is low, medium, high, or red, blue, green, and we encoded them, numerical variables, the label encoding, we gave them the value. For the red, I gave 0. For the blue, I give 1. For green, I gave 2. Make sense? And color is one of the features. Make sense? So if I am giving them according to red, blue, and green, I am giving them 0, 1. That is one way of encoding the data, label encoding. Another way of encoding the data is this, that I have 2 variables or 2 columns, just 2 columns. All right. And let's call it RB. Similar to what we have RBG or RGB in the color codings. All right. For example, if I call it 1, 0, it means it is red. If I make it 0, 1, then it is going to be blue. If I have 0, 0, in English, it means green. So one color column will be replaced by 2 columns. Let's call it color R, color B. We will let go of the color column and we'll just keep these 2 columns. This is called one hot encoding. One hot. This is hot. This is hot. None of them is hot. The third one is hot. Make sense? Which one among them is better for our use case right here? If I'm giving a weightage or a numerical value of 0, 1, and 2, then it is going to affect our model right here, right? Now you have to ask, does the color need to have different weightage, different numbers to it? Because the red one will be skewed less. The red one will be affecting the Y predicted less. The blue one will be affecting more and green one most. Now we have to detect whether these RGB, the colors, are they at a special precedence? Do I give some precedence to these colors? Or do I not give precedence to these colors? If I have a color of the house, red, blue, and green, how does it matter? Why should the blue one will be getting more precedence or the more number than red? Why everything should be same now? Everything should be considered same. So if we are looking at this kind of data, then it will decide whether I should be going for label encoding or whether I should be going one hot encoding at the model level. Make sense? Ajay?
Yeah.
All right. So one hot encoding will be better in that scenario. In this scenario, in this scenario, label encoding will not be better. But if you have ordinality in your variables, that there is a precedence. For example, low, medium, high. I should be giving some precedence more to low, weightage more to low, weightage more to high, medium, weightage more to high. Then I should be having label encoding. Does it make sense?
Yeah, it does. Thank you.
All right. Now let's go to the lab that we are going to do. We are going to do, right now we were looking at the theory. Let's look at the code of the things. Firstly, let's explore. We have done some of the functions of Pandas yesterday, but a lot of functions of Pandas will be coming today. Why? Because they are pertaining to EDA. All right, let's look at the first task, that is the sanity check and the synthetic data we have. Firstly, we have imported the NumPy, the Pandas, and the Matplotlib. Matplotlib is a library which will be helping us building the graphs. All right, and a standard check function to do the checks in our tasks. All right, and then we have a CSV which we have put in here in the form of a data frame, which is having basically the columns of user ID, country, plan. It's basically the churned data that we have, whether the customer is going to churn or not. And we have created a synthetic data over here. All right. The country plan, sign up days ago. How many days ago he signed up? How many tenure days? How many sessions he or she is spending on our platform? For example, we have Netflix. All right. Is he spending more time on Netflix or not? If they are not spending much time, probably they will be churning. All right. Every session on our platform, what is the discount percentage that we gave him? Last payment failed. Whether the last payment failed or not, what is the age? Maybe the senior people will be looking at the less Netflix and they will be churning more. All right. Maybe we'll explore it. All right. Then what we are doing is we are having a data of 20 rows. We are checking that, and we are checking whether we have the target or not. If it has a target, all right, we have any target like chart. Neither we have the data and we don't have the target on it. Remember, we need the labeled data. It is supervised machine learning. And df.head will be printing the top 5 rows of our data. All right. Just one more thing. If I want to print the columns only, then I can do it like this. What are the columns? All right. It will give me the columns. Cool. So this is the initial data that we have. And we are looking at few very important. We are previewing the columns which are high signal plots. What is the sessions? Every session per minute and the tenure days. All right. We are looking at them, their data separately. Cool. The head of the data only. All right. Now what we are going to do the sanity checks. Firstly, what we have to do is we have to check what are the data types. All right. Print data types. This will give us what? It will give us whether we have a variable which is numeric or whether it is categorical. Because the analysis, all the analysis, univariate, bivariate analysis are different, whether it is numerical, whether it is categorical. Make sense? All right. And then what we have to look for is that what kind of churned it is. All right, it is int. We have to check whether it is 0, 1, 0, 1, 0, 1. If it is yes, no, yes, no, yes, no, then I have to convert it later on. But in EDA, I have to catch it. All right. So firstly, look at the data types. Then what we are going to look is we are going to look at the missingness table. What is the number of missingness? What are the duplicates? All right. So in order to, this is not implemented, we'll implement it. We have to make a missingness table in which we have to find and missing. What are the number of missing elements? And what is the percentage of the missing data that we have? And we have to sort them in the descending order. All right. So in order to do that, firstly, I'll take the n, that is the total length of my DFM. Remember, it should be 20. And then I have to check number of missing. How do I find the number of missing? How do I find the number of the missing in one column? In a single column, for example, in age, what is the data which is missing? Is NA. If I print n missing over here, then it should be telling me that in age, which all entries are missing. All right. If I print it right now, it will be telling false, false, false. It is not missing. This is missing. 6th row, age is missing. Let's just confirm it. All right. 6th row, age is missing. All right. So how many things we have over here? 1, 2, 3, 4, 5. This is missing. Make sense? Age is missing, right? That's what it is telling us. And if I want to find out in the complete table, then I can do data frame dot is any of the features. Then it will tell us that in my country plan, nothing is missing. In the age, there is a missing value. In the discount percentage also, there is a missing value. There is one or more missing value. There is some data which is missing. Any gives us that. If I take the sum, then if I print n number of missing, then it is going to tell me how many entries are missing. In age, 1 entry is missing. In the discount percentage, also 1 entry is missing. If I want to take the percentage now, percentage of missing, then what should I do? Is basically n missing divided by total number. Make sense? 20 rows, 1 was missing, so the value should be 0.05. If I print that percentage missing now, 0.05, 0.05 for both these. Make sense? If I want to sort them, then all I have to do is, and we have to return a data frame, right? Miss. So let's have out data frame, which is pd.data frame. Remember, like this, and we will be having 1 row as n missing. Sorry, 1 column as n missing, and another column as percentage missing. Cool. And then we will be returning the out. Return the out. All right. I'll delete this and try to print the missing. Let's print it, and it gives us 0.5, 0.5. But remember, we have to sort the values also. Sort values. Sort values by what? Percentage missing. And ascending, false. Descending, we want descending, no? Ascending, false. Ascending. All right, if I do this, then I'll be having the descending order of missing value. Cool. The next thing that we have to do is the duplicates. Check the duplicates in the rows and the duplicate user IDs. How do I get the duplicates? That in the data frame, let's look at the user ID which has duplicates. df.user ID, user ID, which are duplicates. And how do I find duplicates? Duplicated dot sum. All right. I'll take this as none only for now. Or I'll just do this. Now it is on the data frame. What are the duplicates? There are no duplicates. So this should be giving us 0, 0 if I print it. All right. It should be giving us 0, 0. All right. So we checked for the duplicates. We checked for the missing values in our EDA. Anybody, any questions till now? Let's look at the next task that we have. What we have to do is compute the summary statistics. Remember, the summary statistics will be for the numerical variable, numerical columns. How do I find the numerical variables? Firstly, select only the numerical variables. df dot select d types, data types. Huh?
No.
Include is equal to np dot numeric. All right. This should be giving us, if I print the numerical variables, very important. All right, numerical variables. If I print it, then it should be giving us around data frame. Select d types, numerical, numerical. Numerical is also number. Maybe number will work. number ones. All right. So this will give us the numerical variables. Don't go by this thing. If I want to see what are the numerical variables, then I just look at the columns of it. All right. What are the numerical columns? These ones. It will be interesting if I want to exclude it and I want to look at just the categorical variables. All right. If I want to look at the categorical variables, I will be having two, country and plan. This is the way that we can check the numerical variables or get the numerical variables only, numerical columns in a data frame and the categorical variables. If I want to take the summary statistics, then I have to print the summary also. All right. Print summary also. Print the summary also. Summary statistics, how? To all the numerical variables, I don't do describe. Describe. All right. If I do this, then it will be giving us mean, median, mode. This is very, I don't want to look at like this. It's very difficult to look at like this. So I can do the transpose. All right. And now I'll be having for user ID, what is the count, what is the mean, what is the standard deviation, so on and so forth. Interquantile range. So Ajay was mentioning that we need to have the quantiles high. Right now, the quantiles are like 25, 50, 75%. It doesn't give us any idea that how many outliers are there. I want to find what are the number of elements which are less than 5% and more than 95%. So for that, I can do, what should I do? Percentiles. Percentiles is equal to, I'll take 0.05, then 10, sorry, 1, no, 1, 0.1, then 0.25, 0.5, 0.75, 0.95. Are they 6 now? 1, 2, 3, 4, 5, 6, yes. So let's delete this. All right. So I can describe the, rather than 25%, 50%, 70%, I can have the tailored values also. 5%, 25%, 75%, 95%. And if they are not readable, just do the transpose so that we are having summary statistics as per a variable, numerical variable. All right. This is the way that we can look at the distributions. Now, these are the distributions that we looked at with describe. Another way to look at the distribution is with the plots. So let's have the plots over it. All right. Univariate analysis. Still, we are doing the univariate analysis for a single variable. We want to look at the plot of high signal plots, high signal columns. We don't know that. All right. When we are doing the idea, then we'll come to know that these are high signal. Or the people who are business people which are which are sitting with you. For example, at the end, Alok are sitting to where Alok is a veteran of the churning business, of the e-commerce business. He can give his ideas that look at these columns more. All right. So in the high signals, what we are doing, we have created a figure. We are creating a subplot. Let's create the histogram, plot.histogram. Histogram on what? On the session, last 7 days. And I think it is DF, data frame, last 7 days. And we have to define the number of bins. How many bins of the frequencies that I will be having? I just need to specify the number and it will, under the hood, by default, it will create the bins. All right. Then I can give the title to the plot. Plot.title. Since I have already seen it, I am going to give it a title that it is a skew. All right. And then I can do the plot.xlabel also. Xlabel is session last 7 days. I can give the plot.ylabel as the frequency count. All right. So if I run this, let's see, what does it give us? It gives us a plot. And this gives us an idea about the distribution. That's why we were talking about, right, skewed. And we can do the log transform later. All right. Then I have to refresh in the, there is a bug. Okay, it doesn't go away by itself. If I want to create one more plot, that is average session per minute, then I can do the same thing. All right. Average session minutes, builds 10, session, let's call it average session, heavy tail as the title. All right. Now, if I run it, it will be giving us 2 plots right here. All right. And we can compare the distributions of them. This is right skewed. This is a little bit thick tail. I want to give a little bit more attention over here. What is this doing? It is basically saying that I am creating a plot figure of 10 by 4 size. All right. And we are creating in this plot, we are creating a subplot. Remember, there was 2 subplots. One on this side, one on that side. That complete was the one plot. In that, I have 2 subplots. One row, 2 columns. In the 2 columns, the first column is going to contain the first graph. First row, second column, the second. One row, 2 columns. In the second column, I have the second plot. Now I'm going to do that. I'm going to have 3 columns. And I'm going to have in the 3 columns, the second graph should be this. And the third graph I will be having as, surprise, surprise, a histogram of the third variable that we have. All right. So by changing this, that you get an idea that how to make the graphs actually. All right. The third one is tenure days. Tenure days is range. All right. If I do this, if I print it, now I will be having 3 plots side by side. One is for sessions last 7 days, average session per minute, and tenure days. And this is the way that we can draw the graphs. And what is helping us? Matplotlib. This PLT is coming from where? Right here. From the Matplotlib library. Cool. Anybody any questions till now? All right, let's go to the next one. Target plus analysis. For example, target plus slices. That what is the distribution? Label imbalance, class imbalance. Class imbalance is a general term. Class imbalance is for each and every feature. What is the imbalance? It may be possible that plan is premium only, no basic plan. That is the imbalance in the feature of the plan. In the label imbalance, it is basically the target imbalance. We have to look at the churn rate. If we have to look at the churn rate, all we have to do is in the DF data frame, we have a churned column, right? That is a target column. Just look at the mean of it. Because it is 0, 1, 0, 1, 0, 1. Now, if we take the mean, then it will be giving us the churn rate. The churn rate is about 30%. All right, 30%. All right. If I want to look at the counts, how do I look at the counts? df.churn, value counts. We already talked about it. Value counts. That will be giving us print counts, will be giving us how many zeros, how many ones. What is the error? Series object has no value counts. All right. 0 and count. How many zeros, how many ones? Cool. If we have any other country, what are the different countries I have? Huh? US 7 counts, India 5 counts, Great Britain 4, California 4. All right. Okay. So this is target imbalance checked. That 30% of the label is churn. The 70% is not that much of imbalance. Imbalance is more than 95%. Then we should be worried. 30% is not a very big that we should be. In the matrix, if I use ROC AUC, you don't know it yet. If I use ROC AUC, we will be fine. All right. Not much of a big class imbalance. Then we have to do the slice analysis by country, by plan. All right. We'll do the print by country first. And then print by plan. How do I do? DF country churn rate by country. That is, no. We have to group them by country. Group by country, so that we have the groups by country. And then churned, that is our target, churn, and then the mean. All right. And similarly, group them by plan, because that can give us some insights. For example, if I print, if everything is churning in India and US only, all right. For example, this tells us in the Canada, Great Britain, and India, the churn rate is normal, but there is something abnormality in the churn rate in US. In churn rate, we have the maximum churn rate. All right. Probably people in US don't like us. We are more suited for the other countries. All right. And the basic plan, I have a churn rate of 0.36 in the premium, and that gives us an insight. Premium users are not churning. They are looking at Netflix like day and night. All right. They are paying for it also, but the basic ones are not. Then we are having a tenure bucket. This is a very important slice because we are going to engineer a feature over it, which is a tenure bucket. Because my assumption is that the lesser the tenure, that people churn within very first week or very first 10 days. If they have spent more time on our platform, then they know us and they don't churn. That is an assumption. We are going to validate this assumption by engineering a feature that is tenure bucket. And how do we tenure bucket? I categorize them like this, that if the tenure days are between 1 day to 14 days, I'm going to call it lesser than 2 weeks. If it is between 14 to 60 days, then I'm going to call it 2 weeks to 2 months. I'm going to make a category. If it is between 60 to 180 days, then it's 2 months to 1 year. All right. If it is between, no, not 1 year, 6 months. All right. If it is 180 to any greater than 180, then it is greater than 6 months. This is the way that I'm going to categorize. And for that, what we can do is we can define the numbers like -1 to 40. And then the next one, 60. The next one, 180. The next one, a very big number, so that it is able to take care of it. I can define the bins like this. Make sense? I can define the bins like this. So the first bin will be lesser than 2 weeks. Make sense? Let's code it out. Tenure buckets, pd.cut, pandas.cut, the data frame, which will be tenure days. It will be derived from the tenure days, right? Tenure days. And then tenure days, I will be having the bins, which will be defined like the above, -1 to 14, 14 to 60, 60 to 180, 180 to 1000, 10,000, whatever. And I am going to label. Labels are like that. That is the first bin label will be lesser than 2 weeks. And the second bin will be lesser than or equal to 2 weeks. Then it is 2 weeks to 6 weeks, 6 months, 2 weeks to 2 months, sorry. Then 2 months to 6 months. Then 6 months greater than or equal to 6 months. Greater than or equal to 6 months. Greater than 6 months. All right. These are the labels. If we have to now do it by bucket, then remember I have to change it to df2 because we have created a copy on the df2. There we have created this column, tenure bucket. All right. Group by tenure bucket, churned mean, and print by bucket. All right. If I try to run this, then it should be giving us the tenure, the churn rate by buckets, that 60% of the people are churning if they are less than 2 weeks. Very valuable information. If it is 2 weeks to 2 months, then 50%. Then if it is greater than 6 months, nobody's churning. All right. So majority of the 30% churn is coming from the slices where the tenure days are lesser than 2 weeks. Make sense? Anybody any question till now?
Yeah, these bins are these ranges like -1 to 14?
It is
This is
like
inclusive.
yeah, this is actually
Okay.
this is -1, not inclusive.
Okay.
Sorry, that's a good question. Okay, I'm going to tell you that. Okay, this 0, if I have this 0 is not inclusive. All right, 0 to 14, 0 is not inclusive. This will clarify you. Okay, this is a good question. For example, if I have the tenure days over here, as which column? 1, 2, 3, 4, 5. All right, let's make 1, 2, 3, 4, 5. If I make the tenure days over here as 0, and if I have from, let's print the bins. Let's print the bins. All right, for the better clarity, print df2 tenure buckets. Okay. All right, if I print it, you got it? We get not a number. It's because 0 is not inclusive. If I do -1, then I'll be having the first one is less than 2. All right. So bins are not inclusive for this. For if I want to take 0 to 14, I have to take -1 over it. Similarly, 82, whatever the value. Cool? Does it make sense, Pooja? All right. The next thing that we are, okay, one thing that I forgot is the bivariate analysis, in which we have to draw the graph between two variables. All right. We already talked about the univariate. And if I want to have, not the subplots, if I want to have a 10/4 big figure and I want to do a plot dot for the two variables, scatter plot. Scatter plot between two variables. Which are the two variables? DF. My assumption is every session spent by older people will be less. The younger people will be looking at Netflix more. So every session per minute and the age is what I want to explore. All right. My assumption is if the age goes up, the number of sessions per minute should be coming down. All right. So on the x-axis, I want to have the age, and on the y-axis, I want to have the average session per minute. Cool. If I draw that, let's see the plot of that. All right. As soon as the age is increasing, actually, number of sessions, number of minutes per minute, number of every session per minute is actually increasing. So my assumption that with age, that every session will be less is not correct. My scatter plot is telling that if the age increases, the average session per minute is also generally increasing. It may be because the younger people are working in the companies and the older people are free and they have a lot of time for Netflix. Make sense? One more thing that we will be exploring is the leakage prone features. Remember, the data leakage and the target leakage. If we have any columns over here, one of the leaky columns that we have is the refund after churn flag. Remember, we discussed about it. If we have the refund after churn flag, then it will be directly giving us a signal about the churn, whether the churn will happen or not. So when you are providing the training data, I should be dropping this column. That analysis or that observation is not done at the model level. That is done in the EDA, in the exploratory data analysis. Make sense? That's it. This was the lab for today. Anybody, any questions till now in the NumPy, Pandas, as well as EDA? Tomorrow we'll be doing the balance part of NumPy, and we will be starting with our linear models a little bit. We'll go into the theory of linear models. If you have a little bit of time, then we can go into the theory of linear models as well today. Yeah.
So refund after churn flag is essentially like analysis which we will do, or like it's like
No,
Like
drop it.
we're doing data analysis. So is that something like, let's say we'll figure that out? Like
Yeah,
like, I'm trying to understand the rationale for dropping it.
because it is directly going to give you the target. It is going to lead to target leakage now. Do we want to have the data leakage? There are two kind of data leakages, right? Feature leakage and the target leakage. If one of the columns is directly telling you whether the churn will happen or not, all right, should I be having it in my training data? Make sense, Lohit? Should I be having it?
I mean, we want like the churn outcomes initially for training, right?
Yes. So
Like
it will tell us that, okay, which one will train? It will give us with the full accuracy. All right. Let me ask you this. All right. If I have column for the churn, age, salary, and plan, average sessions, and we are going to make a prediction whether the person will churn or not. So the label churned label will be dropped, right? Why? Because I want to predict and then I want to compare it with my actual label. Make sense? So Y will be the predicted label and this is the actual label, right? With our model, I want to reduce that difference or the what do you call it? The gap between the predicted and the actual. Make sense? So churned, surely we will be dropping. But if I have refund after churn, what you are saying is that my Y predicted will be very, very nice, very, very beautiful. Makes sense? If I have refund after churn, right? That's your argument, right? But my question is, do I need the age and the salary and I can just refund after churn can give me a direct signal. Make sense? That whether the person will churn or not. The other features are not required. Now you have trained your data based upon only one feature. Tomorrow, you go to the real world. And you will not be having refund after churn. Why? Because you are predicting the churn, whether the churn will happen. And after that, you will be making the refund. You have to detect whether a person will churn before he churns. Then you will not be having that data available. Now you don't have that data available. And your whole model was built upon refund after churn. Because you already had the label data. And you have to use the label data to train your model, which you are going to test it in the real world. Good situation, bad situation. Very bad situation, huh? Because this data will not be available to you in the real world. Make sense? So you should be dropping it from your analysis. And just based upon age, salary, average minute, you should be able to detect whether the customer will churn or not. All right. Not with a column which is directly giving you the target. Make sense? Lohit?
So like indirectly, like refund after churn.
Yeah, it is basically Jyoti is in India, it happens. Right? And if you are going to become a doctor, they give you you can buy the question paper also, right? All right. It just happened in the NEET examination. All right. For example, that if I tell you that if you are going to predict from the actual model, then I just fill in the values. You didn't make any model, right? It will not pass in the real world. No? It is basically in your mock test, you already had the answer key and you just put in the answer key. And you're expecting that in the real exam that you will be able to score really great marks. Make sense? So that is a target leakage. That is by definition, it is a target leakage. We should not be having target leakage or data leakage in our model. Strictly no. All right. Anybody else? Any other question? Yes, hello.
Sir, I have a question. I was going through this curriculum and I have realized that this curriculum covered almost 90% of the question being asked in the interview.
Yep.
So I have gone through a lot of YouTube videos and many videos are just, I would say, bogus. So my question is, how are you referencing all these fabulous content?
Yeah, that's a great question. Yeah, that's a great question.
It indicates a lot of hard work and effort, and how much effort what you have been putting to all
Yeah.
these things.
Yeah. Okay, we'll talk about it.
Yeah, Jaspinder, I wanted to ask this question. I've been going through other videos as well, and I don't see any of these specific tips which you mentioned. It's not there actually.
We'll talk about
I'm
it.
really curious, like, from where are you extracting this?
Same types of question they asked me in Global Logic, and other
Yeah.
company asked the same question.
Yeah. Anybody any questions about today's? All right. All right. So we when we were developing the AIML cohort also at that time we went through those videos, and some of them are really amazing, especially Andrew and G. But one of the things which was there was the theory part. The theory part is great, all right, but it is not, theory part doesn't cover everything, and you have to actually pinpoint what exactly you are doing in the model, how you are going to implement the implementation purpose. We are fortunate to have a lot of engineers who are at FANG companies. Just to give you a data, more than 2,500 students of S30 are in the FAG companies. All right, and we didn't do anything we just did the software engineering and system design also. We didn't do AIML, but we were fortunate that a lot of engineers were able to get into the AIML roles because they did the preparation of AIML by themselves. So over a period of 4 months, we went to them rather than getting just copying the thing from the other platforms. What we wanted to do was first principles. All right, that okay, what is getting asked? All right. So what is getting asked? So with each and every topic, let's try to do that. Okay, what are they going to ask it? This is the normal way that we can do the NumPy, and rather than that, this is the actual things which are getting asked. All right, and then completing that picture that okay, we need to make it a lab. We may need to make it end-to-end task. All right, so somewhere you'll see that we are still in the initial phase of these labs platform. Somewhere you'll see that the tasks are not continued. All right, they are not flowing in that manner. All right, so that is one of the things that okay, that is the strategy or the framework that we made, that okay, this should be the framework. Then it was going into for making the AI, we used AI. All right, so this is the framework that we have for this topic. This is the framework. And what else should be there is the discussion with the very frontier models and very premium models that we interacted with. We interacted with the premium models also. So taking the feedback from the industry, from the people who are actually recruiting, who are actually the Meta AI, Inderjeet, Komal, who is VP at one of the companies. All right. So, and she has throughout her career, she has been an AIML person also only. So, and she has been an instructor at S30, and she is associated with S30 from last 10 years now. All right. So, getting all that feedback from them, getting the sources from them, that no, send me the code, send me the things, write it down, and then working it with the AI ML, and over a period of, so that's why it took us a little bit of 6 months, 7 months period of time just to have the first draft of the things. All right, and that's how we were able to. Still, it is not perfect. We are still, you'll see that some of the labs will be breaking, some of the things we will be adding, deleting. But the methodology or the thought process was that okay, if I have to get into FANGs, what is me and Raser should be preparing. All right, because we both are the AIML people right now, and we went to a lot of people who are professors at the great tech companies like IIT, NITs, and some of them are good, some of them are not that good. But to align it directly to the FANG interviews is what was the motive, and we had to do it from the first principle. All right, does that answer your question? It is a very long answer. I don't know whether it answered.
You have answered, but in between I just I don't know, I lost the connection, so I will go through the recording. But I would really appreciate that this content is really high tech, because whatever interviews I was going through, the same kind of, if they are going to ask from ED, same kind of question they ask, not more than this.
So we actually pinpointed it. Okay, what was asked, the questions are FANG tip, FANG gotcha is what is written over it. All right. Anybody else? Any other question?
Yeah, I have one more question. So, what was the thought behind pulling in a bit of linear algebra and PCA before getting into the math?
What was the rationale behind in the NumPy getting the PC, right?
Yeah, I
Okay.
was taken a bit back because we did not cover the usual thing is like, we go NumPy, Pandas, Matplotlib, and then EDA, and then we jump into the math. But then I was a little surprised to see PCA and linear algebra coming a bit earlier before we get into the math.
Yeah. So that is okay, let me stop recording first. Okay. So when I was talking about that, okay, we have the data, the model, and the matrix, all right, and the engine for them is NumPy. Without the engine, we are not able to do anything. So I knew already in the NumPy that we will be doing some of the things which should be covered in the mathematics. All right. But we can keep waiting for everything to cover and then come to NumPy. All right. So there was a strategic decision that we had to take that the compute is the most important thing, or you have to get into a mindset of NumPy, because neither you get into a mindset of scikit-learn or the PyTorches or the other libraries. We wanted you to bring you to the mother or the root for the computer science students, and that is the compute. And we already knew that there are going to be some interferences. For example, that interference that, okay, you should have done softmax in order to understand the stable softmax. But that is a chicken and egg problem, that for the mathematics you can learn, and then don't know how to do it in the compute. So in that scenario, you will be asking me that, okay, we have done the mathematics, but you have not done the compute. That's why we took a strategic decision that compute is going to be the root or the mother ship, which is going to drive everything. So let's focus on the mothership, and some of the things students might not be able to learn, might not be able to understand directly. For example, softmax. What is softmax? You don't know that, right? How is that derived then? But the idea was that you do not be worried that how is the softmax calculated, where that formula of sigmoid, for example, for sigmoid, where is that formula for 1 plus e raised power minus z is coming from? All right, you don't worry about it. But if you have the formula, how would you implement it using compute? Is firstly you should be knowing. For example, you do not know what are the eigenvalues or what is the dimensionality reduction. But if you have to do it, if you have to implement it, how would you implement it based on NumPy itself? Make sense? That was the decision that we took. All right. For the couple of batches, for the 3 batches, it has brilliantly worked for the students. For some of the students, it has worked like this, that I didn't understand what is eigenvalues exactly, but I understood how you are doing it. I understood why you are doing np.linearalgebra.solve. I understood that part, but I did not understand exactly how the eigenvalues are working. And that gets covered in the mathematics parts, and then the light bulb goes on that, oh, this is what he was trying to do. Make sense, Sam?
Yeah.
All right.
And one more question.
You are right now assuming, because I have not covered the np.linearalgebra.solve. I have not covered the linear algebra.eigens. All right. When I go to that task, just like pairwise distances, I was able to do it on the whiteboard, that this is the way the pairwise distances I will be doing. And it can happen in the KNN. I don't have to cover the whole KNN model for that. I can just give you a matrix, and this is the way that we are doing. Oh, this is the way that we are driving. That's why I'm doing square plus square transpose plus -2 of x transpose at the rate x. All right. I was able to make very clear about it. Well, this is how I am doing the pairwise distancing by taking a1, a2, b1, b2. We are going to do the same thing in eigenvalues as well as eigenvectors as well as the linear algebra.solve, which is basically solving the equations, the linear equations.
Okay.
But so still there will be some question that what is linear models? Where is this formula coming from? Let them stay there. All right. they'll get covered. Because if I keep waiting for them to be covered and then come to the compute, then we'll not be able to come to the compute ever. And we cannot leave neither, every NumPy tutorial is just covering about the shapes. They don't even cover about the memory. They don't cover about the broadcasting. They do not cover about the PCA, how PCA is implemented using NumPy. They do not cover how NumPy is going to take care of the to the linear for solving the linear equation. Make sense? Till the time you do not see the capability of a tool, you will not believe it. Yes, Ajay, go ahead. What's your question?
Jaspinder, I appreciate your effort in this. I have a question. So the curriculum it covers a broad range of topics, but then I mean AI is very vast, right? So some could go into certain specializations like convolutional, computer vision, or so. So based on this course, what are the typical roles that we could target after finishing the course?
So,
yeah.
firstly, what this is a very natural assumption that everybody makes, that okay, we are going from classical machine learning. We are not even classical. We are going from the NumPy EDA, and then the mathematics part of it, then the classical machine learning, then the deep learning, then the advanced deep learning. Then we are going to go to from deep learning, the CNNs, and then we are going to go to the NLP, LLMs. Then we are going to go to the RAGs. Then we are going to go to the ML system design. Then we are going to go to the agents. That there is end-to-end chain basically in this cohort. Did you ever realize that we are not going to the depth till now?
I mean, I believe we would in the future, though. Right?
We will be doing the same kind of thing in the deep learning part also. In fact, you will be seeing that initially the classical machine learning will be done without any library, where you will be building your own scikit-learn in classical machine learning. There is nothing beyond that. Imagine a student who is building his own scikit-learn, basically building his own models. Who will be better than them? In convolutional neural networks, we will not be using library, we will be using NumPy. Who will understand more than that? In the NLP or in the LLMs, you are building your own ChatGPT with NumPy. Who will be more better than that? Make sense? So we do go to a lot of depth. That's why we say that, okay, it is very intensive cohort. It's not an easy cohort. All right. It's very intensive. But the kind of depth that we will be doing is, after that, you tell me that, okay, whether you were able to, we are missing some of the stones and not. All right. Apparently, we are not going to the PhD level also. All right. But it is surely greater than that of MS level. All right. Yes. Lohit?
Yeah. Maybe just to answer Ajay's question, I mean, the thing which we covered today, EDA lab. So I know, like I work at Salesforce, so I go to office where there's AI research team, and there's this entire team which is just working on data cleansing part, and I don't know how will they how do they grill it, but yeah, to answer your point, I think every aspect like for every aspect in end to end AI ML, I think this is just data exploration, so there's a separate team and separate research on that. It's just what you want and what you want to be interested in. That's a call which I would say. But yeah, just when I mean, I feel this I think my initial view is that I obviously did DSA with you, so I feel this is very much syntax oriented.
Little bit. Initially. Okay.
Yeah.
Here's a comment. All right. When we are doing the lab at that time, it is syntax oriented. You don't worry about the syntax. If you understand the earlier part, now that what are the rationales? All right. What are the gotchas, or what are the things that we are trying to figure out? All right. If you are able to figure out the why part in AI/ML, then you will be fine. You don't need to be worried about the how part. that how you are actually doing the tech test, how you are actually writing the code. For example, you can very well forget about that, okay, df.describe is going to give you the statistics. And we came with this assumption only that, okay, you will be using the ChatGPT. In fact, that is one of the things that we gave in the platform itself. Go use ChatGPT. All right. Go ask them that, okay, if this is the task, how will I code it out? All right. We are not worried about it. You will be, and the future of the AML field is going that, okay, the coding will be done by the machines only, all right, by the models only. It is the thinking that you will be done. So you will see that, okay, we are trying to develop the thinking process behind it. That what are you trying to do? How are you going to do the univariate analysis? What are you trying to do in the bivariate analysis? And one of the prime examples is the missing values. MCAR, MNAR, MR. All right, what are you going to do about them? Don't leave it to the machine. Make your own strategy in that. That if it is MNR missing not at random, then is missing is the flag that you should be doing. Make sense? Not just randomly putting it in me. So it is just if you don't focus, if you don't understand the syntax, I don't know this. I falter on the syntax also. All right. All right. I am going to falter a lot on the syntax also. All right. So syntax is fine. It's going to be the why part. If you are able to understand the flow, what you should be doing, you should not be having this column. It is the discussions that we have in the class rather than the coding part, which is going to be much more useful. Make sense, Lohit? And initially the syntax is, and let me tell you one thing, all right? Nobody will be asking to make the model themselves. They'll be giving you the model and they'll be giving you the things and they'll be asking you that, how should I be doing it? What should I be doing it? Make sense?
Yeah.
All right. Okay. Yes, same.
Yeah, Jaspinder, you mentioned that we'll be building the algorithms from scratch. I know that's the hard way and the right way to do it. But do we cover any frameworks and libraries
Yes,
ahead
we
in
do.
the cohort? Because
We do.
the
We
reason
do.
to ask it is
We do.
the hands-on book which you suggested, right? So the third edition, it's full of PyTorch, but the previous ones, it's like, Keras, scikit-learn, and TensorFlow. So which libraries do we cover in this?
No, scikit-learn we will be using for machine learning, but once you have built the things under the hood, then you'll not be worried whether I'm using PyTorch or whether I'm using TensorFlow at the deep learning level. All right, you'll be fine with both. You'll be able to read them. Make sense?
Yeah. And one more thing, I'm having payment issues.
Yes,
I'm not able
scikit.
to make the payment.
Yeah, it will. You can just. It's fine. I'll figure it. I'll fix it. Okay, separately. Bye, guys. Have fun. Anybody else? Any other question?
Hey, Jaspinder, I had a question about the class imbalance and outliers, right? What is the difference? So, like in pandas, outliers you can do z-score, right? For class imbalance, can you give example? Like in pandas, how can you? Because some things you don't know, right? The outliers are something which is unknown, right? So, how do you model that? Like so.
So class imbalance and outliers. Okay. So class imbalance. Are you talking about the label imbalance?
Means numerical, you could take an example. Numerical, like, how far is it from the mean and standard deviation, right? That's like is something called outlier.
That is not the imbalance. That is the imbalance is the representation in your target. For example, in the target imbalance, in the label imbalance, label is nothing but the target. That how much is the representation of all the classes. For example, if you're trying to figure out whether disease, no disease. If I have no disease data or the entries only 2 and rest 98 are disease entry, that is class imbalance. It's not the missing. It is the representation of a class. The disease class is 98 times and the no disease class is 2 times. Make sense? That is the imbalance.
I see. Okay.
All right. That is the imbalance that we are talking about. And that kind of imbalance can be there in case of other features also, not only target, other features also. For example, the plan. If I have 2 plans, basic and premium. If I have basic, only 98 lines of basic and only 2 lines of premium. All right. Then we have a imbalance in the feature data. Feature is what? Plan.
So what is the cutoff Got it. But what is the cutoff? Like three standard deviation, we say, right, for outliers. So in this
So that is
imbalance, like,
outliers. That is totally different from the
okay,
imbalance. All right. So for the outliers, we have to make a decision whether we are dropping the outliers or not dropping the outliers. All right. I gave you an example that if it is celebrities and you have a normal neighborhood, then you should not be. Then you should be dropping the outliers. But if you are having a place where we have outliers of the celebrities, but the celebrities are moving over there, West Hollywood hits, then you should not be dropping the outliers. All right, that is for outliers. Now the class imbalance. What your this thing is that okay? What is the cutoff for the class imbalance that I should be dropping? We should not be dropping. If you start dropping, or if you start changing the data, then it is not representative of your real population. Firstly, understand the class imbalance or the label imbalance, target imbalance can very well happen in the real population. It is representation of the real population. All right. For example, in the real population, unfortunately, the cancer disease patients are going to be 1% out of 100. And that is a real representation of the complete population. And my data is going to be a sample of that population. So if I have 1% of the data, 1% of the people with disease, then that is actually the true representation of the population. Then I should not be worried about that. Okay, I will try to forcibly take more people who are diseases. Then you are trying to have a sample or trying to develop a model on not the true representation of the population. Does it make sense, Rakesh?
yeah, I understood. I just did not get the point. Like sometimes outliers is what we're looking for. Like for instance, let's say we are getting engine data, like flight data, right? And there is something happened on the engine, some malfunction, right? So there is a spike. So that's the outlier. So sometimes we need the outliers, right? So why we should ignore the outliers and
I think what I mentioned was depends upon your situation whether you should be ignoring the outlier or you should not be ignoring the outlier. Imbalance and outliers are two separate concepts. First, all right. So we are not talking about imbalance now. Let's talk about the outlier. For the
Right.
outliers, you should be ignoring the outliers if it is not as per your use case. For example, I gave that you are in a normal neighborhood, but in that neighborhood, Alok, who is Mr. Adani, who came and who took a house which is of one, and he paid the price for it $1 million. Doesn't mean
Right.
that the normal pricing of the houses is $1 million over there. It may be $100,000 only. But if you are staying in a society where it is less West Hollywood Hills, in which few of the celebrities have taken it for $2 million, and some of the people who are old people who had taken it 100,000 people, then you should not be ignoring it. Then you should be taking that outlier into the account that if it is a celebrity, he is going to pay in millions. Make sense?
Makes sense totally. Yeah. I think
Yeah. So it
that-
depends upon the use case whether you should be ignoring the outliers or not ignoring the outliers. But in the usual cases, if it is general cases, if you are doing the outliers and you are fitting the model with the outliers, then the outliers are going to skew. For example, these are the few outliers. All right. And rest of the data is right here. Then generally this should be your model.
correct.
But if there are many outliers, you'll end up fitting your model like this, which will not be the good representation of your prediction that you are trying to. That's why
Right.
these outliers should be ignored so that you have a model like this, which is the true representation. Does it make sense?
Yes, totally. And the imbalance thing, can you give example like next class, using pandas, how can you model it in uh,
At the model and the matrix level, we will not be doing it right now. We'll
okay.
handle the class imbalance. How to handle the imbalance at the model at the matrix level later on. Neither we will be
Got
boiling the ocean. All right. But I just wanted to cover on this part that how to detect the class imbalance. Because in
it.
exploratory data analysis, we'll be detecting. Does it make sense, Rakesh?
Yes, I understood the difference now. Yeah, it makes sense.
Yes, Alok, go ahead.
Sir, I was having just same kind of question that there are a lot of things in AI and I really have a less time. to upgrade things. So you are saying that if I go inside the code, it's really going to take time. So instead, I will focus on the design part and the concepts behind the, like in the AI, I would say machine learning, how to tune this model and all these things. Because if I just go through the code, it will take definitely time. But I just want to quickly.
In army, one thing is there. All right. Till the time you are not in trenches and you have not worked in the trenches, then you don't know how to point your weapons. All right. You can read about the tactics, about the strategies, about the concepts, and number of time. You can listen to me. Till the time you have not actually you have not gone through the labs by yourself, you will not understand it. I understand, but probably S30 is not the best place if you are trying to accelerate your learnings. We don't have, and we figured it out that, okay, in the DSAs also, we need to have 4 months at least, so that the learning is step by step and the students are able to come up to a level. Same is the concept over here also. All right, I can give you the concept right away. It's already there in the theory of the labs. You can just read them. All right, but I highly doubt, without the discussions in the class and without looking at this at the lab level, that you will be able to absorb much of the thing. Make sense? So I don't have a shortcut for that. I wish
No,
there was this accelerated way of doing the things. I'm not the best person for that.
No, in AI, it's not, there is no accelerated way. And even I'm going through the code, but I'm just trying to balance what are the interview questions they are focusing more.
That can be done. Bye, guys. Have fun.
Thank you.